Okay, so for here, I'm going to summarize just a few of the high points from some of the IPython notebooks that we have about web crawlers. So up on the screen right now, I have our list of them. And so the ones I'm going to talk about are the ones I'll highlight right here. And I try to do something good, but the pen's not working. I made it work, so let's try it one more time. So these right here, all the i427 underscore crawling ones. And in terms of the order in which we encountered them, just a reminder, dealing with the URLs is the one that we found first, or the one that we dealt with first. Robots.txt was the second one, and then of course the summary is the third one. So the important thing to remember about the summary is that it has the pseudocode for the project, and so it's the one that we kind of think about as it has our version of a web crawler in it. But we've looked at these over lots of different classes and with Spring Break in the middle, and sometimes we had to deal with kind of really low-level details of URLs and stuff. So the purpose of this video is just to kind of attempt to tie things together in some sense. So what I have is a blank IPython notebook, and I'm going to try to use the notebooks to build up a little bit of a demo of a web crawler. Not something that'll work for the project, but just something that kind of shows you what these things might look like when they're in action. And so the first thing I want to deal with is the what we talked about with the URL. So I'm going to look at that notebook, and I'm going to steal the import statements from the top, because we might need those. And I'm going to put them into my IPython notebook. So I have a tab for that. And so, okay, there they are. So a reminder about this notebook. The big picture of this one was the idea that we need normalized URLs. That's what this thing focused on. That was its purpose. And so to that end, what we're going to do is we're going to do the best we can with the URL parse. And so that gives us these two things that we're going to make a lot of use of: URL split and URL join. The other things we're going to need: URL lib, that just lets us read in HTML, and so that's what we need when we actually visit a page. And then the one in the middle, the beautiful soup, is the one that we actually need to get anchor tags, to get links for our web crawler. So we use it for that. So those are the big three things we need. As far as how we use the URL split method, there's an example of it. We give it a URL, and then that's all we have to do. So what I'll do in the IPython notebook that we have on the other screen is I'll give a starting URL, and I'll use a different one. I'll stick with the Ada server. But I'll use the home page, so it's just index.html in my home directory for the web server. And so then I'll use, so I'll have a starting URL. If we want to split the URL, we can use URL split. If we want to read in HTML, then we can also do that stuff. So I'll take this code, because I'm going to need it. So now I'll start evaluating stuff. Before I do that, I'm going to think ahead just one little bit, and I'm going to know, well, okay, wait a minute, we also have to deal with robots.txt and stuff. So I'm going to try to remind us what we need for that, and the only addition is that we need the robot parser. So I'll bring that in as well. Then hopefully I'll be through with the imports, and it doesn't matter which order they're in, so I'll evaluate them. I have a starting URL. If I use URL split, it doesn't work because I'm doing everything too fast and not paying attention. The problem is, well, URL is not defined. That's easy to fix. I'm using a different variable name. So there we go. We can remember that the network location, the netlock part of the split URL, is what we really need. So then if we want to know what domain or what server are we starting on, we can get that with the netlock property. And then if we want to, we can print it out. And there it is. That's what we expect, ada.ius.edu. And so now if we want to say, okay, this is the server we're dealing with, let's make a robot parser for that. So I know I'm hopping around notebooks, but I'm kind of trying to give you guys a sense of how the web crawler actually works. That we need to get the URL, we need to get the robots.txt file. In the notebook, we saw actually how to read it in using URL lib, but we also saw, oh, if we do that, we get into all of this stuff, all of these disallows that we would have to parse individually. So what we can do instead is we can construct a robot parser object that will handle all that complexity for us. And so the URL that I want to use for this is going to be our starting domain, ada.ius.edu, and then after that /robots.txt. So now I have an RP object. The main thing that we get with the robot parser object is that we get a can fetch method. And so we give it the URL that we would want to read in, and then it'll tell us if we're allowed to read it in or not. So it tells me it's okay, I can go ahead and fetch it. So the robots.txt file for ada.ius.edu, if it exists, allows us to read in our starting URL, which is my home page. So now that we can fetch it, we're able to get its HTML contents. So to do that, we need to open the URL and we need to read it. And so then once we do that, we have the HTML from our page. So I'm using the URL lib module. It's URL open function, and so what it expects is a string that holds the URL, and so then we can read it. So now I have the HTML from our starting page, and so now what I need to do that I have the HTML is I need to get all the links that that page has. At this point, when I have HTML, I can also save it in the database if I want to do that when I'm writing the web crawler. So to get all the different links, I need a beautiful soup object. And what I build that from is the HTML that I just got. And I stored that in HTML from page. So I'm purposely using different variable names than we've seen before so that we can kind of focus on what each one of these methods wants. That I started at a particular URL, and I call that starting URL. From that, I split it to get the domain that I'm starting at, which was ada.ius.edu in this example. Given that domain, then I can construct the robot parser. So I did that here. Once I have that, I can ask if I can, according to robots.txt, read pages on the server. That's what I'm doing here. Once I know I can read a page, once I get that it returns true, then I can use URL open from the URL lib module to get HTML. When I have that, I can build the beautiful soup object. And so then at that point, I can find all the links. So now I'm looking back at the robots.txt file. And I'm going to take this code here. I'm going to take it all. I'm going to copy it in here. So this is pseudocode as far as I'm concerned. I'm going to rewrite some of it. But remember that soup gives us a way to find all the anchor tags. And then for every one of those anchor tags, we can find out if it has an href attribute. And if it does, and it actually holds a value, so one that's not equal to the empty string, then what we can do is we can normalize that URL. So there's a lot of stuff going on here, a lot of stuff that it's worth kind of writing out what it's doing. So here we're getting all the anchor tags. Here we're only keeping anchor tags that have non-empty hrefs. So only use ones with non-empty href values. And so then after that, what we're doing, I'm going to erase for a second. Not very well, apparently. Okay, so that's what we're doing with this part. And then finally, the other thing we do is we use URL join to normalize the URL. So these are all the key things that our web crawler has to do, and this example is showing us how to do them. So the only thing I have to worry about though is I got this code from another notebook. I need to change some things because I'm using different object names here. So if I want to do that, let me clear the highlighting. So I have a soup object that's going to find all the tags. It's going to get the href. So the new URL, if I want to normalize it, I need to have my current URL. And so I didn't call that starting URL. I think I called it starting. I'm going to scroll back up to double check. So yep, starting _ URL. And so then I can get all the href values. And so then I have a robot parser and I can say, can I fetch it or not? So what I'm going to do at this point is in my if statement here, I'm going to give two print statements. So I'm going to say we can fetch in this case, because the robot parser told us we could, and we always do what it says. In the other case, we cannot fetch it. So now if I do that, if I look at what I get a bunch of links, and it says, okay, we can fetch some of these. We're good to go. As far as what the web crawler says, remember the web crawler project says that we want to stick to just a specified list of domains, and we hand that list in with a constructor. If we look at this, some of these are okay. And so when we're doing the project, what we would say is, okay, our starting domain, ada.ius.edu, this one's okay, this one's okay, this one's okay, this one's okay. So far we're doing good. Oh, this one is not okay. This one's not okay. Good, good, bad, bad. So only some of these would we like to add to the database. So it's not enough just to look at what the robot parser tells us, but we also need to do a little bit more work. So in terms of what that work we need to do is, let me clear the screen here. Let me get the mouse pointer back. So we made a normalized URL. We have that. And when we've done that, that was actually kind of the point of the first set of IPython notebooks. It took us a class and a half, but basically all it was to illustrate URLs are complicated. Do this, and we have a good one. So that being said, what we want to do now, we want to know which server the URL is going to be on. And so with that, if we look at that, we're going to use the URL split again. So I'm too lazy to type, so I'm going to copy paste it. I want to take this normalized URL that I just made, and I want to call this domain to visit. So now I've split the new URL that I just found. And so with every one of these links, now that we know which page we started with, and so let me add a comment to that up here. So every link we find is from the current page which is stored in starting URL, and then every link is to the normalized URL stored in URL to visit. So now at this point we have enough information to add something to our links table in the database if we're doing the project 2. So then we can see, okay, the domain to visit we split, and then we want just the network location. And so now I'm going to add some more printout stuff here. And so if we do it again, we can see, okay, so this page, the one that I said was okay before, if we do our system of checks again, this one's good, and the reason it's good is because the domain is the same as where we started. The ones that are bad have a different domain. So then what we can do is we can actually check based on that then. So it's okay, it's great the robot parser says that we can fetch it. That's good, but that's not enough. So, and we also want to know whether the domain that we'll be visiting is, if it's equal to our starting domain. And so I'm going to scroll back up and make sure I'm using the right variable name. There it is, so I'm okay. So now if we do the same thing, let's see, now things have changed. Now our logic is a little bit more precise, and we can recognize, oh, okay, here it's saying no, we cannot fetch this one. We can't get ius.edu. We can't get this one. Can't get this one. So now we're doing pretty good. So if we think about what's going on here, is that in this part of our code, this is a page that we can fetch. So now we can think this is a link that we can put in the database. This is a link that we can add to the queue. So as far as what we're doing, the pseudocode for this if statement, the high-level way we can think about it is that it has two parts to it. One part has to do with the robots.txt. The other part has to do with a good domain. So here, the good domain just means we're on the same one that we started with. For the project, it's more general than that. And so this code will not be sufficient for the project. For the project, what we have is a list of domains. And so what we really need to check is that if the domain to visit is in the list of allowed domains. So at this point, we've taken one web page and we've kind of broken it up into all the links that it has. And we've recognized, okay, sometimes we just ignore the page, bad page. Other times we can actually add it to the database, add it to the queue. And so what we have in terms of this thing is that this is what we're going to do for every one of the pages. And so what we really want to think about for this pseudocode, or this Python code, and I'm on a slippery slope when I'm calling Python pseudocode, but that's basically what it is, that this is where we start. This is with a page that we just popped from our queue. Popoed, if you can't spell. And so this is something we do over and over. We do it while our queue is not empty and while we still have other links to visit. So this is basically the driver for our web crawler. And then the other thing we need to realize is that, okay, when we've done this, once we've actually read this page in, once we've processed all the links, then maybe we need to take a little break. And so then we also want to sleep for a few seconds. And to illustrate that this actually works, I'll evaluate it one more time. I have a print statement after the sleep statement. And the reason for that is, oh, bad Kimmer, he didn't import time. So yes, one of my powers is importing time. And so now if I evaluate it, and so that's kind of interesting, but it actually took it longer to do this because it went to sleep first before we got all the output. And so then we get that down here. So all we need to do, this is basically a pretty substantial part of what we'd have to do for the project. It is in some sense an attempt to tie all three of those IPython notebooks together with the important parts from each one. And so one more time, the important part from the first IPython notebook is the fact that URL parse lets us normalize URLs. And we do that with the URL join function. We also need to know a lot of information about the domains we're visiting. And so we get that with the URL split function. And then after we've done that, we extract off the netlock attribute. So that was the important stuff from the first IPython notebook we had. The second one we had, everything that was important about it was with robots.txt. And so what we need to remember as far as the project is that we can check for every one of the pages, and moreover, every domain that we're going to be visiting, every network location that we have has its own robots.txt. So we have to use the one for the appropriate domain. If we use the wrong one, then it'll tell us, sure, you can fetch. Why would ada.ius.edu tell you whether you can fetch something from ius.edu or not? But that everything about the second notebook boiled down to this robot parser can fetch function. The third notebook was an attempt to tie everything together, and so it just gave us some pseudocode that has to do with adding things to the database and sleeping for a few seconds after every page. So this is just a quick demo of how we would process one page in our web crawler at a higher level of detail than we ever saw in class.